When massive floods and landslides struck Sumatra in late 2025, thousands of tons of mud, rocks, and wood were carried by the currents. This wasn't just water, it was an element revealing ecological damage upstream, a pattern clearly emerging from satellite imagery and concession maps. Extractive activities, including mining, energy projects, industrial access roads, and monoculture plantations, played a significant role in increasing flood and landslide vulnerability. Today, we will uncover the scientific mechanisms behind this, not to assign blame, but to understand how industrial landscape changes drastically increase disaster risk.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Sumatra is a hub for extractive industries, including gold, nickel, and coal mining, industrial timber plantations, large-scale palm oil, and energy projects. Many of these operations are located in the hydrologically sensitive upstream areas of watersheds in Aceh, North Sumatra, and West Sumatra. What happens upstream directly impacts downstream areas. Damaged forests, exposed soil, and accelerated water flow lead to larger floods and easier landslides. Land clearing for mines, industrial plantations, or energy projects involves clearing, leveling, and creating access, which removes root systems that hold soil together. This reduces the soil's capacity to absorb water and increases its erodibility, making it prone to washing away during extreme rainfall. Industrial roads, often overlooked, cut through hills, concentrate water flow, and create artificial drainage channels, increasing runoff speed by up to 300%. This phenomenon, known as longitudinal water acceleration, turns these roads into giant pipes channeling water directly into upstream rivers during heavy rains. Extractive activities also disturb microtopography through excavations, industrial terracing, and temporary water depressions. These changes disrupt natural seepage patterns, leading to unstable water accumulation, spontaneous landslides, and concentrated water flows, explaining the disproportionate material volume in the 2025 floods. Large-scale industries often target upstream areas for proximity to resources, inadvertently destroying the most critical parts of the hydrological system. Primary forests slow water flow, stabilize slopes, and absorb vast amounts of rainfall. Without them, extreme rain creates massive surface runoff. Exposed soil from extractive activities leads to significant sedimentation, causing river shallowing, channel narrowing, and increased flood frequency. Infrastructure like dams and canals alter natural hydrology, modifying river paths and disrupting sediment transport, making systems unprepared for extreme loads. The Batang Toru Hydroelectricity Company project in North Sumatra exemplifies how ecological and social impacts were ignored, threatening endangered species and increasing disaster potential. While a single mine or plantation might not cause a disaster, the cumulative impact of multiple extractive activities creates a catchment collapse. This collapse severely compromises the hydrological functions of the watershed, turning extreme rainfall into tragedy. Industrial roads can increase water flow speed by 3 to 5 times, and each hectare of open-pit mining can increase sedimentation by up to 40 tons annually. Oil palm monocultures have infiltration rates similar to semi-impermeable surfaces compared to primary forests, and 80% of major flash floods occur in watersheds with combined deforestation, access roads, and mining. In disaster science, major catastrophes are never caused by a single factor, the atmosphere triggers, but land conditions determine the extent of damage. Extractive activities are not the sole cause, but they create vulnerability, transforming extreme rain into tragedy. To prevent future disasters, environmental management, sustainable development, and stronger enforcement of regulations are crucial. This includes halting destructive operations, implementing sustainable land use practices, and restoring degraded ecosystems. The Sumatra disaster reminds us that catastrophes are often amplified by human actions and policy choices that prioritize short-term economic gains over long-term ecological balance.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.